If someone told you that there were hidden giants all around us, you'd probably assume they were talking about something like the Bigfoot Sasquatch kind of thing. But if instead they were referring to geothermal power plants, you'd probably believe them because, well, they do exist. You can even find several of these energy production facilities near where I live here in Oregon. But how much do you really know about them? How are these so-called giants actually powered? What are their pros and cons, and what could we learn from them that might help us make our own cities greener? Welcome to my channel. First off, let's talk about what the Cascades are. In case you didn't know, the Cascades is not only a mountain range but also a source of renewable energy. Technically, the Cascade Mountain range extends all the way from British Columbia down through Washington, Oregon, and California before ending at the Mexican border just south of Mount Shasta. There's also a small spur of the range that continues south into the Great Basin called the Ruby Mountains, and yes, for all you geography nerds out there, the Cascades are technically part of the larger Pacific Ring of Fire and have been formed over hundreds of thousands of years by the subduction of the Juan de Fuca microplate beneath the North American plate. This means that, along with being home to some pretty epic ski slopes and hiking trails, it's also home to many volcanoes, including some of the most active ones in the contiguous United States like Mount St. Helens, Mount Hood, and of course the behemoth that is Mount Rainier. So now that we've covered the basics of where the Cascades are and how they got there, let's talk about why they're so special when it comes to producing energy. You see, because the Cascades contain so many volcanoes, the magma chambers deep below the surface of the Earth are particularly active. This results in places called geothermal fields, which are areas where large amounts of heat can be extracted from the Earth via steam. And it just so happens that these fields often overlap with areas where there's already infrastructure in place to harness this energy. It's basically a perfect scenario for producing clean, reliable baseload energy, right? Now, if you're one of my viewers who lives outside of North America, you might be thinking, wait, don't you all get most of your energy from burning fossil fuels? And to that, I would say yes, but we're trying to change. One of the biggest challenges facing North America, especially the United States, is the need to replace coal and natural gas plants that are being phased out due to their detrimental effects on climate change. As such, geothermal energy is being looked at as a viable alternative because unlike wind or solar energy, it provides constant, reliable power. If you want to hear more about why geothermal is considered a green energy source, check out this video up here. But for now, let's talk about the history of geothermal energy production in the Cascades. The first geothermal power plant in the region was the Geysers, which began operations in 1960. Located about 100 miles north of San Francisco in California's Mountains, the plant gets its energy from hot water and steam produced by the Earth's magma chamber located approximately 4 miles underground. Since then, the area has expanded to include dozens of wells that drill as deep as 12,000 feet, allowing the facility to produce enough electricity to power about 750,000 homes. In fact, as of the writing of this video, the Geysers is the largest geothermal complex in the world. But what makes the Cascades so special is that this is only the beginning. Just north of the Geysers is the known geothermal resource area called the East Mesa, which contains 187 square miles of heat-producing magma. To put this into perspective, the entire state of Connecticut fits within the boundaries of this single geothermal field. Even though all of this energy is currently being harnessed, it's estimated that only a fraction of the total heat is being used. Estimates suggest that up to 13 gigawatts of power could be produced from the East Mesa alone, enough to power about 13 million homes. Of course, the Cascades aren't just special because of the sheer amount of energy that can be produced. The real value lies in how this process works. So let's take a look at a typical geothermal power plant and find out just how much power we could be getting from the Cascades. In order to generate electricity from geothermal energy, we need to first access the heat source, which in most cases is steam. And the best way to do that is by drilling deep into the earth. Depending on the site, wells can reach depths of anywhere from a few thousand feet to over 12,000 feet, which allows them to tap into the heat generated by the planet's core. Once a suitable depth is reached, the steam rises to the surface through pipes called production wells. At this point, the steam is separated from any non-condensable gases and then sent to a turbine where its kinetic energy is converted into mechanical energy. After passing through the turbine, the steam condenses back into water, which is then pumped back into the ground via injection wells. This process of pumping water back into the ground serves two important purposes. First, it helps maintain the pressure in the reservoir, which keeps the steam coming. Second, it allows the water to be reheated and used over again, making the process highly efficient. Once the steam has done its job of generating electricity, it's then cooled and condensed back into liquid form and pumped back down into the earth via injection wells. This process of cooling the steam also recovers some of the energy in the steam, which is then used to heat the water that's pumped back into the ground. This helps maintain the pressure in the reservoir and ensures that the steam continues to flow to the surface. But what exactly makes geothermal energy so promising? Well, unlike other renewable energy sources like solar and wind, geothermal energy is available 24 hours a day, 7 days a week. It's always there, ready to generate power whenever it's needed. This reliability is what makes geothermal energy so attractive as a potential replacement for fossil fuels. Coal and natural gas plants provide constant, reliable power, but they come with a hefty carbon footprint. On the other hand, geothermal plants are much cleaner, emitting little to no greenhouse gases. In addition, geothermal plants have a relatively small land footprint compared to other energy production methods. Solar and wind farms, for example, require large areas of land to generate the same amount of power as a single geothermal plant. This makes geothermal energy an attractive option for countries like the United States that are looking to reduce their carbon emissions without sacrificing energy production. However, despite the many benefits of geothermal energy, there are also some drawbacks. For example, geothermal plants are expensive to build and require specialized equipment and expertise. In addition, geothermal energy is not available in all locations. The ideal location for a geothermal plant is in an area with high volcanic activity or tectonic plate boundaries, which makes the Cascades a prime candidate. But there are other parts of the country where geothermal energy is not as accessible. Finally, geothermal energy can have some negative environmental impacts, such as the release of greenhouse gases during drilling and the potential for seismic activity to be triggered by fluid injection. However, these impacts are generally much less significant than those of fossil fuels. Despite these challenges, geothermal energy is still a promising option for countries around the world that are looking to produce clean, reliable energy. In fact, many countries like Iceland, Japan, and New Zealand already rely heavily on geothermal energy to meet their energy needs. These countries have realized the potential of geothermal energy and are taking advantage of it to provide power to their citizens while reducing their carbon footprint. What's really exciting about geothermal energy is its potential to help us move away from fossil fuels and towards a more sustainable future. As technology improves, geothermal energy is becoming more efficient and cost-effective. Who knows? Maybe one day we'll be able to harness the power of the earth to provide all of our energy needs and protect our planet for future generations. Thanks for watching. I hope you learned something new and found it interesting. If you did, be sure to subscribe for more updates.